Hi everyone. So I will talk about design patterns in the front end. So a real-life Angular architecture lessons. First, I will present myself. So I'm a software engineer and tech lead in a company called Pedenaud Fintech. So we help clients to structure and develop their application, or we have also some migration projects. I'm also passionate about debugging, and I am, as said, a camp counselor, becoming director. So I work with young people, like teenagers, during holidays. That's it. So for the story, about 1 year ago, I arrived on a new project to help a client. So for the context, this is a huge retailer in electrical gear with an e-commerce platform to migrate. In this platform, there is a CMS called Appliance that we have to migrate. So there are some static pages with content types, and we have to migrate it in an Angular app. So there is one migration to do, one CMS, and we have 22 content types to migrate. This is a big thing for us because we had to do it in a really short time. So to continue with the context, if I describe the thing we had to do, so the CMS we had to migrate looked like this. So if you were a webmaster, you had an interface like this. So you can write a title, add some subcomponents, add a subtitle, and then you can preview your static page for the e-commerce site. Then it will render like this. So this is an example of a page in this e-commerce site. So you have some components, for example, a content type called carousel, and inside the carousel you have another content type, so a sub-component called the card link, then an image, a link, everything. So we have a lot of content types to migrate, and some of them are dependent on one another. So we wrote, we designed, we drew a dependency schema. Here is the dependency schema. So we can notice that there is a shared structure across the components. They are nested and reusable content blocks, and we have some type-specific behaviors and logic. So actually, it is more allowed nesting than dependencies. For example, a card can have button, but it is not necessary. That's it. So when you see this and you think that you have to migrate all of this, you can say, how can we possibly do this? I mean, in a clean way, because it can really fast become messy. So yeah, we just paused with my team and we said, how can we possibly do this? And then we had a meeting where we discussed about building an engine. So we did a meeting, we talked a lot, how could we design a system that could render all those contents in a proper way, so with this dependency tree and everything. And so we thought about an engine. Sorry for my accent. We designed an engine, and so we thought about building a strategy pattern plus a composite pattern with dependency injection. So all of this in an Angular application. If you don't know design patterns are software design that you can use to solve some core software problems. It is more used in backend software, but actually it's just like software engineering. So you have 3 core problem design patterns can solve. creational design patterns to create objects. Then structural design patterns, it explains how to assemble objects and classes into larger structures while keeping them flexible and efficient. And then you have behavioral design patterns that are concerned with algorithm and, and the assignment of responsibilities between objects. So when we thought about this, we thought this is exactly the problems we want to solve in this case. So why this engine? Why a strategy pattern and a composite pattern and using the dependency injection of Angular? So as I said, design patterns are typical solutions to commonly occurring problems in software engineering. The strategy pattern solves the behavioral problem. So it permits us to avoid a huge if cases file, because you have, when you want to render all those content types, there is a moment when you would like to use some if cases, like if I have video content, then I want to render the video component. Then the composite pattern helps us to solve the structural problem, which was basically the tree dependency. So there is, when you see the tree dependency between the contents, you see exactly that there is a composition problem. And then we used Angular tools for the creational pattern, so this is like a kind of factory, and to have a seamless implementation of the strategy pattern. So let's deep dive into those design patterns. Strategy pattern is a design pattern that can, basically it helps you to avoid a big if cases file. So, for example, you have different strategies that are quite the same but different in in a similar way. They are similar, but they have some differences. For example, you want to implement an application to do transportation. You have 3 strategies you want to implement. Take the bus, take your car, or going by your trottinette. I don't know the word in English. And to implement this, so you have a context, then you have an interface, an interface that implements some strategies, and then you can choose between the strategies. So each time you added a new routing algorithm, the main class of the navigator doubled in size if you add a if cases file. At some point, it became too hard to maintain. But then the strategy interface, so the strategy interface is common to all the strategies. It declares a method, so the method execute, for example. The context uses to choose a strategy. So the context delegates the work to a linked strategy object instead of executing on its own. So, oops, there is no images, sorry. But to explain the meme, there was a big if file and a photo of a candle and a developer praying for not breaking anything. So you go from a big if cases file to just creating a new component without touching the engine. So this is our file typology we implemented. So you can recognize our strategies. As I said, in backend software development, the strategies are logic business. But here we want to render different components. So our strategies are basically Angular components. So for example, a link component or a video component. So these are our strategies. Then we have some files for the engine. So a content service for API calls and having the data. A registry which choose the strategy, so the right strategy to render. And a decorator. I will explain why we used a decorator in this case. And then finally we have a file called the builder to build our page we want to render. So first let's talk a little about dependency injection. So dependency injection is a design pattern used to organize and share code across an application by allowing you to inject features into different parts. Basically, the problem it solves is that it permits easier sharing of behavior across all the code base and decouple the usage of responsible unit from implementation. I think you all used something, dependency injection, just when you do the constructor, parentheses, service one, etc. But by default, DI works, so dependency injection works with classes, so services, but sometimes you want to inject some different data, like for example, a list or configs or everything. And that's where injection token comes. So injection token, it lets you register and inject typed custom values. And in our cases, actually, we want to inject a list. I will talk about it later. So instead of calling a service, you can inject a map or list or anything. So here are the tricks for the Angular implementation of our strategy pattern. First, we created a map in the registry. So it's a simple map that mapped the content type from the CMS. So we add the data from the CMS. For example, we have a link content type. We want to say that the link content type has to be rendered by the link component. That's it. In the code, it's just this. So it's just a map that maps the content type from the CMS to the component class we want to render. This is the first brick of our implementation. Then we added a decorator, which is a TypeScript feature. So we use a custom decorator that automatically registers new components into that map. So developers don't have to touch the registry manually. It just happens when they declare a component. In the code, it just shows like this. So we created our custom decorator, and then we added it in our components. So for example, appliance, which is the name of the CMS, at appliance component, video content. And then the last trick for our Angular implementation is using the injection token. This is where it becomes really, really powerful. It's the use of the injection token. It lets Angular inject this whole registry dynamically at runtime. So when the app starts, Angular already knows every component that was decorated. We never have to import or wire them manually. So I will show you how we did it in the code, and I think it will make sense. So we have our map, as I said earlier, sorry. And then we have so the injection of registered components by the appliance components token. And then we traverse all decorated components and add them to the map. So we don't have to do it manually. So this is in the registry service. And then in the decorator service, so this is where we declare the injection token to provide the list of the registered components. Then we add the decorated components to the global table. And then we have a function, so provide appliance components function that provides the components registered by the dependency injection. Without injection token, we would have to export a static list and maybe pass the list hard-coded into the module. So the decorator registers the components. The injection token exposes that registry to Angular's dependency injection system, and the service consumes it. That's where the automation comes from. To just talk about it a little more, without the injection token, with the injection token, the components register themselves by the decorator. Angular injects the list automatically, and we can scale easily with modular code. But without the injection token, you would have to maintain a global list manually, import and pass the list manually also, and then it can become really messy as soon as the app grows. And as we had 22 content types to migrate and maybe other content types to create later, I mean, in 1 year or two, this couldn't be possible. Or we would meet some great problems. So using the strategy pattern to dynamically render the CMS content or link content inside Angular. So this is our implementation. This is another sort of schema to explain how we did it. Each content type is associated with a component responsible for rendering it, and this mapping is abstracted by a registry service. And if you want to have a last touch of magic on this strategy pattern, we can talk about the app builder, because as I said before, we also have an app builder file that helped us to create a component instance at runtime, inserts it into the DOM inside the current Angular view, and then it enables dynamic data-driven UI, like the ViewContainerRef.create component. It instantiates and renders an Angular component dynamically at runtime, inserting it into the template based on the data rather than static HTML. So in short, to conclude about this strategy pattern, so we can recognize the context with the page builder component. We also recognize the strategy interface with the registry service. And then, of course, we recognize the strategies in the components. But there is still another problem to solve, which is this composition of the contents. Like, as I said before, we have a big dependency schema, and we had a problem to choose which content we want to render, but we also have a problem how to compose those contents, because as I showed you, in a code link, for example, you can have an image and a link and everything. So this is a nested structure. And this is where the composite pattern comes. So there is a little image, a little picture that can describe what is a composite pattern and what it can solve. Basically, it looks like a tree. So when we saw the dependency schema, we quite instantly recognize the composite pattern. So for example, you work at Amazon, for example, and you have a box in which you have to put another box, in which you have to put maybe another box, and then a phone or the thing you want to deliver to the people. Here, how do you implement it? You have a client, then you have, just as in the strategy pattern and interface, which choose which method to execute, and then in the methods you want to execute, there is two ways to do it. You are either a composite, so for example a box, either a leaf, so the object you want to deliver, so you're the end of the chain. It permits to respect the Liskov substitution principle. So it means that objects of a subclass should be usable everywhere. The subclass is expected without breaking the behavior. So you can change those objects, and it helped us managing nested content blocks with a single abstraction. So basically, the strategy was for rendering an individual block, and the composite is to render the block tree. This is a file typology for the composite pattern. So as I said, we have the interface, the CMS content reference to have the data from the CMS. Then we have, which is really like the most important to recognize, the leaf service and the composite service. So basically it's like a recursion. And then we have the same page builder from the strategy that helps us to render the tree. In the code, it's just shows like this. So we added a new set for the leaf or composite thing. So I didn't need more Angular magic. The strategy pattern had already given me a dynamic rendering pipeline. So with the composite pattern, I only needed to orchestrate how blocks combine, not change how they are rendered. That's why I did not really change the builder. Indeed, the registry drives everything. And the other block of code that I changed was actually in the builder, because with the in the builder, sorry, because here now we have a factory that decides between leaf or composite, and then we just use the same method to render either a leaf or a composite. So with the strategy alone, the page builder decided everything itself. And the page builder also performed fetching, which is not a clean way of coding it. And there is no abstraction for the leaf versus composite thing. But coupled with the composite component, the factory decides leaf versus component, and so the builder doesn't know what it's rendering anymore. So this is a cleaner way to implement it. And then we have also a unified interface, so zero additional logic. No fetch, no recursion, no dynamic component creation in the builder anymore. So where's the magic trick here? Actually, there is no Angular magic trick in the composite pattern implementation. All the Angular magic tricks were in the strategy pattern implementation. Here we just used the architectural we implemented before. So if I had to show you how it is with the composite pattern, well, we just have this HTML that renders any content page. So the only thing the developers has to write is this little piece of HTML, and then with our architectural implementation, it can render every content page. So we respected the promise. The system finds the right Angular component, it renders it recursively, and adding a new CMS block only means creating a new Angular component. We don't have to touch the engine when we want to add a new content. So for the little conclusion, I had my colleague that said we usually say that design patterns are a backend thing, and I think that's one thing you have to keep with you. Front-end engineering is also software engineering. We tend to associate design patterns with Java Spring thing or backend thing, but actually front-end apps face the exact same problems, which are managing complexity, reusing logic, keeping things flexible. The only difference is that in the front-end, we use objects or components or services and templates, not always business logic, but when we start seeing them as a larger system, we can see that patterns like strategy or composite factory become just as useful as in any backend application. And if you want a little comparison, we usually talk about applications with 3 layers schema, so the presentation layer, the logic layer, and the data layer. But actually, if you transpose it in a front-end application, the presentation layer is just templating. The logic layer is your services and utils files, and then your data layer is the API clients or storage. So our front-end applications are also software engineering, and we are engineering. We solve problems every day. We build systems, and that's the message I wanted to deliver you today. Thank you.